So the last part of this section is influential observations. And so a lot of the time we're like, what's the difference between an outlier and influential? Well, recall that an outlier in this chapter with regression analysis, that outlier was when the distance from the regression line to the observed value was so large, much larger than any other distance or residual, that it becomes an outlier on our residual box plot, right? Well, influential is actually more of like how we thought of outliers before this chapter, of where if we have one value, let's just say we're looking at average income of the United States workers. We have celebrities and billionaires like Bill Gates, and the Tesla CEO Elon Musk, that they're billionaires, and then you have these people that can't find a job and they're barely making it paycheck to paycheck. Well, we could take a million of these people down here with a certain lower income, a million of them, and they still wouldn't be, if I added them all up, as much as Bill Gates, who's a billionaire. So Bill Gates can influence the average to be what it really, like our average household income could be $1 million, when that just isn't really true reflection of the American population. And in fact, the average or the median household income is like about 40 to 50,000 a year, because we have to identify these influential observations. So these influential observations are those ones that can influence the average, like to go pull it down or up, right? Where prior to this, it was outliers that just showed the residuals that were so large that it became an outlier for the residuals. So what we're going to do is we're going to take that drilling example and grab its linear reg information, correlation coefficient and stuff like that, and then add a value and then determine whether that value would have been influential. And we would tell that it would be influential because what would change? The relationship, right? That relationship and the significance of that relationship would adjust and be different. So right here, I just wrote a little definition in the box about influential. It's just an observation that significantly affects the least squares regression line. And so it typically exists when a point is an outlier relative to the other values of the explanatory variable. So just something that can weigh it down or up. So let's go ahead and go back to the drilling data. And what I'm going to do is I'm going to take the original linear regression information. So here it is in list 1 and list 2. So I'm going to go ahead and just run a lin reg of my original. Really quickly. So here's the original. This is with all the data values that were in example 13.1. So this is the original. So now what it wants us to do is add in a depth at start depth of 300 feet, and then saying that it took 12.49 minutes to drill 5 feet. So let's go ahead and add this point in. So now let me go back to the calculator. Let me go back to stat and edit. And at the very bottom of list 1, under 190, let me add the 300 start depth. And let me go to L2 and add that time of 12.49 minutes. So remember what this means? This means that if I started at a drill depth of 300 feet, it would take me 12.49 minutes to drill 5 feet. So I'm adding this number. Now just look at our scope of our model. The largest depth we started at was 190, and now I'm skipping way outside the scope of I'm going like 110 feet deeper, right? So it's a little outside the scope of our model. So let's see if this value can influence any of our other parameters that we got originally from this data here. So let's run a linreg test. Let's go to stat and go to calc and go to 4. And you're going to run the same list because it already knows that it has that extra value. And so I'm just going to hit calculate really fast. And so let me drag this in there. Okay. And so now let me go ahead and write in that this is now with the extra point 312.49 minutes. Was it influential? Well, look at my R, 0.773, and look at my correlation coefficient now, 0.868. Now, what did this point do? Did it create it to pull it down or pull it up? Well, since it was a deeper depth, a larger, deeper depth, we expected it to pull it up, right? Like to pull that everything up, and it did. Notice that the correlation coefficient used to be 0.773 and now it's 0.868. So to write this down, so since R squared and R increased, the point 312.49 was influential. So just kind of doing the contrary, like why was it so influential? Because this value was outside the scope of our model, right? Let's just say we go back to stat in the list, and let me go back up here. And let's say I didn't go outside of the scope of my model. Let's say I started at 191 feet, and it took, I don't know, 8.1 minutes. So I'm staying within the scope of my model. Let's see if even adding 191 and 8.1 influence. So if I go back to stat and go to calc and 4, and now calculate it not with the 300 one, but changing it to that 191, look at this 0.801, 0.642, and look here, 0.77, 0.597. So you could see that it still wasn't influential. It was still influential to have that additional, but not nearly as much as the 300, where it was about a, from the R squared perspective, you could see that it was about a 15-16% difference. So even if you stay within the scope of the model, what you really always want to do is seeing if it's an outlier. You would do the box plot on the residuals to see if it's influential. You would go ahead and compare the R and R squared.